Okay. As you may remember, let me start from the beginning of this part of your slides. Okay. Can you see the slide now? Can you see this? Okay. As you may recall, we've talked about different types of distributed systems. Okay. First, I discussed the distributed computing system, which is used for high performance computing and is one of the most important types of distributed system. But we have another type which is called distributed information systems. Can you hear my voice? Can you hear my voice? Yeah, guys, I think some of students have a problem. Okay. Please, someone tell the other students which have problem with voice to log out and log in again. Okay, in Arabic, please, someone tell them, and I try to write it in English. Okay. Thank you, dear Marwa. And thank you, dear Hossein. So, in distributed information systems, as its name indicates, the focus is on information. And what we mean by information and what operations we want to perform on information is usually two categories. Let me write it for you here. Let me write it on the board. Okay. Now, information related actions. We have information processing. Also, we have information storage and retrieval. Okay. These are two important disciplines when we want to talk about information-related actions. Okay, information processing and information storage and retrieval. You know, working with information, sometimes called, let me write it here for you, data manipulation. Data manipulation. Working with data is called data manipulation. For example, you may want to update data, you want to read data, you want to delete, you want to add, okay? As I told you before, we have four basic commands for data manipulation. Data manipulation commands. These commands are used to work to manipulate the data. First is the read command. Second is update command, which we use to change some parts of information. Third one is insert or add new command. And the fourth one is delete command. Okay, we have these four commands, which is usually called CRUD commands. And for example, in SQL language, we have these four commands. For reading data, we use a command called select. To update data, we use a command called update. For adding new data, we use a command called insert. And for deleting data, we have this delete command. Okay. Hi everyone. Please pay attention and avoid typing in the chat box while I'm using it as your some kind of whiteboard. Okay. Hello everyone, and thank you for your greetings. But please try to focus, because I use chat box for teaching. Okay, so we have these four basic commands, which is called CRUD commands: select, update, insert, and delete. We use these commands to manipulate data, okay? To change data, to retrieve data, or to store data, okay? Data manipulation. And also we have this information processing, which is something more advanced. Information processing is much more advanced. For example, let me type it here for you. Information processing is more advanced than these primitive commands. Okay. For example, you may want to do some information processing on, for example, you think you have more than 100,000 of images, okay, and you want to do some machine learning on these images. For example, you want to use them to you want to use some machine learning algorithm, some deep learning algorithm to classify this image. For example, you want to classify different kinds of animals. For example, dog, cat, horse, I don't know, elephant, lion, tiger, is an animal. Algorithm to train some model and classify these images, so you will be able to classify some image. When we fit that image to the computer system, and it can say, okay, this is an image from a tiger, or this is an image from a dog or a cat. Okay, this is information processing. It has higher levels of working and manipulation and reading and inference than these primitive select, update, delete, and insert commands. Okay, so this is higher level. Let me okay. Currently, we don't talk about the information processing. In these slides, we focus on information storage and retrieval, and the systems, the distributed systems, which is being used for this task. Okay, does anyone have any questions? Does anyone have any question? Okay, if you have a question, you can write your question. If not, it doesn't necessary to write anything else. Okay, so one of the most for your homework, I don't know, I told you before, but it's necessary for this portion of your course. These homeworks, okay? Work. Okay. Loop file system. I told you before, but now I'm emphasizing on it. MapReduce and Hadoop to Spark, Apache Spark, and 3, big data. These 3 things should be studied for your homework, okay? No, this is your homework, dear Hussein. This is your homework. You should study these 3 concepts: Hadoop MapReduce, Apache Spark, and the concept of big data. I mean information processing. No, dear Hussein, let me explain with more details. When you want to process information, you need to use some frameworks. Okay, you need to use some tools, some algorithms. And one of the most famous frameworks is Hadoop. And Hadoop follows a programming model which is called MapReduce. MapReduce. And also, you have another technology. Please, students, I will answer your question in the chat box. Don't worry, I will answer all of your questions, but one by one. Apache Spark is another technology which is being used to analyze and process large amounts of data in smallest fraction of time possible in most cases. So these are 2 technologies. Hadoop and Spark are 2 technologies. MapReduce is a programming model which you should study. And I think this is your answer. And also the third item is big data. You should know what big data means. You should study and learn what big data means. I think that you may have a course in your period of study, in your graduate studies, which is called big data. You should have a course called big data. Okay, but now here I want you to read the basics of big data. What is big data? What is the difference between big data and data? Okay. Now, please, guys. Okay, 5 students ask me, 4 or 5 students ask me, how should they send their homework? You shouldn't send this homework to me at all. Okay, you should just study and learn them, because these homeworks are candidate questions for your final exam. So in final exam, maybe you may have a question which is which transaction. I told you that transaction is basically, and with an informal definition, is a set of commands used to manipulate data like this. For example, look at this transaction, begin transaction here, read this information, write this information, new data is this, and if some condition, then do this. If another other condition, then do this, and end the transaction. Okay, this is a sample. This is a simple transaction. You can see here, and let me show you another real example of transactions. Just a second, and I will show you a good example. Okay. Now you can see a transaction here. Here, guys, can you see this image? Can you see this new image? Okay, this is a real transaction for, okay, thank you. I got that, you can see it. This is a real image, real transaction written for Microsoft SQL Server. Most of you may be heard about Microsoft SQL Server transaction. For example, here we have begin tran T1, update table 1, begin tran M2 with mark, update table 2, select something, all columns from table 1, commit tran M2, this one, and update table 3, and then commit tran and T1, this transaction. Okay, here we have two transactions. This transaction is nested within this bigger transaction. This is a simple transaction you can see here. And this is a real transaction, actual SQL Server transaction. I see some students write something. I don't know, you have any question? Guys, do you have a question? Dear Al-Hassan Muhammad, do you have any question here? Dear Barzan Muhammad, you wrote that can you say any app and program you're using? What is your question? What is your question? And dear Hassan Al-Hassan Muhammad, please ask your question. I don't understand your question. You wrote some sentence. And it's not in the form of a question. Dear Barzan, what is your question? Using application what? Can you write a complete sentence? Using application for what? Dear Barazan, can you explain more about your question? Are you asking about what application me specifically using for storing and retrieving data? This is your question? And dear, this programming language is called Transact SQL. Or Microsoft SQL Server. SQL Server Transact SQL. Dear Rasul Faiq, do you have any questions? I don't know this text. Do you have a question? Or you just... So why did you write this? Okay, dear Barzan, me specifically, I use several database systems. I use SQL Server. It depends. It depends on the type of the type of project you are involved with. Okay, I use SQL Server a lot. I use PostgreSQL. I use, in some cases, I use MongoDB. Okay, these are the most common database application I use, but I know that many developers use other type. For example, many of them use MySQL. You may heard about. I don't use it. Okay, dear Rasha Samad, can Microsoft tools be used to develop a real estate transaction data? You know, dear Rasha Samad, Microsoft tools can be used to create any application you think about, any application. Okay, just you should pick the right tool and learn the proper method to develop your application. So with Microsoft tool set and tool suites, you can develop any kind of application you may think, from games to advanced enterprise solutions to government applications or small mobile applications, and any kind of application you may think you can write with Microsoft toolset. You are welcome. Okay. Okay. Does anyone have any question? Okay. Another homework for you. Another homework is just see what SQL is. What is SQL? I don't want you to learn SQL with details, although I expect software engineers, computer engineers to be able to work with SQL. But here I want you to learn the basics of the concept of SQL. You know, SQL is a structured query language. It's a programming language. It's specifically used to for data manipulation and data definition. Okay. SQL is used in Microsoft SQL Server, in Oracle database servers, in MySQL, in PostgreSQL, in SQLite, and many different database systems. Yes, structured query language. Okay, another question. I don't want you to study SQL Server, okay? I ask you to study what is the SQL language. SQL itself. It's a language that is being used in SQL Server, in PostgreSQL, and many other database systems. So focus on SQL, okay? Let me give you a link. You can start from here. W3 Schools can help you to learn some basics of SQL. You know, this website, W3 Schools, should be your friend. You know, you should frequently visit this website and try to spend your time in this website, because as an engineer you must know different technologies to be able to perform real things. Okay, dear Al Hassan Muhammad, I don't know, is it a question you wrote, or you just try to give some more explanations? And also, dear Ali Faisal, do you have any question? Dear guys, don't send me your answers about, I don't know, SQL or big data or any other thing. Just read and learn for yourself. Okay, don't send me anything in private chat. Or I checked my email now and I saw that some students sent me some emails regarding these homeworks, but no, just don't send anything to me. It doesn't require. I just want you to learn these things. Okay, any other question? Okay, let's go back to our slide. Okay, please read this paragraph. The vast amount of distributed systems in use today are forms of traditional information systems that now integrate legacy systems. Legacy systems. And this example, guys, just a second, Salam. Dear students, just a second, and I will return to class. Dear students, let's have a break for I think about 15 minutes, and then we'll restart our course. Okay, let's continue. An important sentence wrote here, has been written here as a note, transactions form an atomic operation. So what atomic means here? We can say atomic means that we cannot make a transaction to smaller parts. So a transaction will either commit or abort. So it may, let's see this. Okay, here you can see that transaction here may be aborted, and here will be committed. Commit or abort. So we cannot say that for a transaction, some parts of it will be wrong and some parts will be neglected or maybe failed. Okay, this is not the case in the transactions. Transactions are atomic. We have different properties regarding transactions, as we discussed in the previous session, and I want to review these again. First, atomicity. These four properties is called acid properties. Acid properties: atomicity, consistency, isolation, and durability. We know them as acid properties. First of all is atomicity. So as I mentioned in the previous slide, in a transaction, all operations will succeed or all of them will fail. All operations either succeed or all of them will fail. So when a transaction fails, the state of this is very important. This is very important. When the transaction fails, the state of the object will remain unaffected by the transaction. Okay. So for you want to buy a ticket to you want to reserve a hotel, you want to buy a ticket in that for the museum in that city, and these actions should follow some atomic scheme. So if you buy hotel and if you have buy hotel and in hotel written performed hotel payments, and also you've buy, for example, ticket to the museum, but you couldn't find a ticket for airplane, so this transaction will fail. And when it fails, we need that the system roll back to its previous session. So the system should roll back to its previous status. Okay. So it seems that we don't have any payments and hotel payments, and we don't buy any museum ticket. This is rollback. Okay, rollback. Let me write it here for you. Rollback. This is rollback. Okay. Is there any questions here? Is there any question here about atomicity or acid in general? If anyone has question, please write a dot like this, and then I will wait until he or she completes their writing. Okay. Okay, it seems everyone is fine. So let's continue with consistency. Consistency means a transaction will or should establish a valid state transition. Valid state transition. So, for example, consider this one. Let me write here for you. Consider this scenario. This is my account. Just a second, so I upload a blank page here, and then we will continue to that. Okay, this is my account, and this is, for example, Tom's account. Excuse me. Tom's account. Okay, I have considered this. I have about $1,000 in my account. And Tom has $200. Let's see a transaction here. I write it here. Begin transaction is equal to my account is equal to a minus 500 write B to Tom. C is equal to Tom account. C is equal to C plus B. Right. A to this is my transaction here, and let's see what really does. What it really does is transfer $500 from my account to Tom's account. Okay. So now let's go. What happened here? Let me write it right. C2. Okay, now it's correct. Just please, everyone, can you see the image now? Can you see the image and the writings on that? Okay, perfect. Okay, so please study this transaction here. Please read the command. Dear Ahmad Ibrahim, you should find the recorded sessions, the voice and the slides from previous sessions to catch up to other students, okay? So, dear guys, this is a transaction, and please focus on the slide. This is a transaction which can transfer $500 from my account to Tom's account. Okay. You know, atomicity means if for example the transaction fails in this step. Transaction fails in this step. Let me write it here. This step, for example. Okay. If it fails, then my account will be this. My account balance will be $500, and Tom's account will be $200. It's strange because $500 is now lost because here, in here, these commands were run, and now the amount of money is decreased. The amount of my account is decreased, and as we can see, the amount of money in Tom's account hasn't increased yet. So this is inconsistency. This is what we call inconsistency. Inconsistency. This is not correct. We can see why. Where is my $500? It is not in my account. Also, it is not in Tom's account. It is not in my account, neither in Tom's account. This is not good. This is inconsistency. But what database do to prevent this? If it fails here, and as I showed you before, $500 is my account and $200 for Tom's account. After failure, the system will update. The system will update this and tries to roll back to this number. And also this will be rolled back. Of course, I know it hasn't changed yet, but it will roll back. This is what we call rolled back. And after roll back, the accounts will be like this. $1,000 for my account and $200 for Tom's account. This is correct. It's correct, and we don't have any problem with this. Okay? This is what rollback means. So when a transaction fails in between its operations, the system will roll back to previously known correct situation, or the correct word is status. So in this case, the balance in my account will be changed to $1,000, and the balance of Tom's account will be changed to $200. This is how rollback acts. Because if we haven't done such a thing, we will have these two wrong numbers. My account will be $500, and Tom's account is $200, and $500 will be lost in between. Okay? This is very important to learn. Okay. Does anyone have question? Guys, I know that you have questions, but I really worried about this situation that you don't ask your questions. Or I should assume that all of you know these things and so on and so on. It's so strange. Okay, it's up to you. If you don't want to ask your questions, it's up to you. I'll be glad to see your questions and answer them. Okay, dear Rasha Samad wrote, maybe we exceed our withdrawal limit. In that case, the card is restored to normal by itself next day. No. This is not what I meant. Not even close. Not even close. Dear Hossein, yes, ABCs are temporary variables. Dear Mohammed Salim, yes, if the transaction is not committed by the system, then all the chains will be rolled back to its previous, to its initial state. Good question, dear Ali. The database itself has this ability, and it will be performed automatically. Another question? That dear Ali Abdul Karim asked is very important. Let me write it here, the answer. Transaction processing is performed by database engine automatically. Okay. So if the transaction commits, then the final values should be written to the database, and if the transaction fails at any point, then we should roll back to initial values. Another question? Okay, so let's go back to our slides. So this is what is called atomicity, and also we've discussed consistency, and in which, for example, if money has been withdrawn from my account, in between these money transfer, something happened, that money should be returned to my account to preserve consistency. Another thing here is, let me discuss this first. Another thing here is durability. It means that after the transaction completed and committed, the result should be permanent, should be written to the database, and should be permanent. Okay, so after it's some kind of obvious that we want that the result of a committed transaction to be permanent. Okay, this is obvious, but we should mention it here. This is durability, and then we have this isolation. You know that in a database system, we have multiple users, maybe thousands or 10,000s or 100,000 or even millions of transactions may be processed by a database system in a concurrent scheme, concurrently. A database system may process multiple thousands of transactions at a second. Okay, let me show you. Let me show you the image here. Okay, if this is our database system, database management system, or DBMS, and this is transaction one of user one. Also, we may have transaction two by user for user two. Let me write it for you. Okay, transaction two. Oh, what happened? Of user two, and here we have transaction one of user three. Then we have transaction, I don't know, transaction one of user n. As you can see, let me draw some lines here. Okay. For example, user two has two transactions, user one has one transaction, user three has one transaction, user n has one transaction. All of these transactions, all of these transactions will be arrived at this database system. For example, let me write it here. These transactions will arrive at DBMS at, for example, 8 a.m. Okay, so attention to this. So we have different transactions here, and all of them arrived at the DBMS at 8 o'clock, 8.2, 2 minutes past 8. Okay. So the point here is all of these transactions will be run in a concurrent scheme. Concurrent scheme. The database system will try to execute these transactions transactions concurrently. So we should have some mechanisms to let these transactions to perform concurrently. This is what we call isolation. This is what we call isolation. In isolation, each transaction thinks that it is the only transaction in the system. So it appears to each transaction, for example, T, that other transactions occur either before T or after T, but never both. So this is what is called serializability. This is what is called serializability. Oh, sorry, let me correct it here. Serializability. This is what we call serializability. In serializability, it means that although we know that multiple transactions are being executed, are being run in parallel in a concurrent scheme, it seems to each particular transaction that it is being executed alone. All transactions will be executed after it or has been executed before it. This is the theory of serializability, and you may heard about it in your advanced database system. I don't want to involve with much details, much theoretical details regarding this thing, but you may heard about it. Isolation guarantees that these transactions think that they are the only transaction in the system. Okay, these are the ACID properties. And if you have any questions regarding these properties, you can shoot them here. Okay, no question? Perfect. So what I wanted to tell you in this slide, let me go back a little bit. Okay, is that we have distributed information processing systems, and one of the most important and common forms of these systems is distributed information systems. And in distributed information systems, we usually work on running transactions, and transactions are the basic units of work in which we pack some data manipulation commands, and usually they have ACID properties. Okay, this is the review of this slide, important slide. Now let's proceed to the next and last type of distributed systems, which is called distributed pervasive systems. You may heard about something which is currently a buzzword, Internet of Things, IoT. Yes, I think many of you has been heard about IoT. Or Internet of Things. These two terms are currently used interchangeably. What we mean by distributed pervasive systems is usually the thing that we mean by Internet of Things. Okay. This is the emerging next generation of distributed systems in which nodes are small, mobile, and often embedded in a larger system. Okay. For your homework, first, let me say this to you. For your homework, study a computer named Raspberry Pi. Let me show you an image of Raspberry Pi. Let me show you an image. Just a second. Okay. This is a Raspberry Pi computer system. Okay, it is a complete computer system in the side of a car, in the size of a card, a credit card. It's so small. It's so small. It's a computer, and I think its price is currently, I don't know its price. I think it's near $100. I don't know, maybe less. Let me check Raspberry Pi. Oh, it's so cheap. It's 55. Actually, it's 55. It's $55. It's a full computer system. It has everything. USB ports, LAN port. It also has some modules to enable SIM card, Wi-Fi, Bluetooth. Also, it provides a HDMI port to connect to television. We use these computers to teach students, teenager students, and graduate students to work with computer hardware and basic computer systems. You know, it has an operating system called Raspbian. It's a Linux operating system. Also, you can install Windows IoT on these devices, Windows 10 IoT on these devices. This device, you can make robots. You can make your own home automation system. You can make smart homes with this computer. It's so cheap and it's so powerful, and it's a complete system in the size of a cardboard. Okay, let me show you another image of Raspberry Pi. Okay. Yes, this is a good image. Now you can see. Just a second, guys. Let's see, something is happening. Okay. Look at this image. This is the real size of a Raspberry Pi. Actually, you have HDMI here, you have power port here, you have all different things here. This is a complete computer. You can use it without a box or case. and you can do anything you can do with your computer. You can have Microsoft, you can install different applications. For example, you can install Microsoft Windows, the IoT version of Windows, or you can install a Raspbian or other Linux operating systems on this, and you can have applications such as like similar to Word and Excel. And also you have different programming language to use on this computer. You can use Python, you can use Java, you can use C, C++. And lots of power relies in this simple and small computer systems. Okay, actually we use this system in several projects. For example, we made a hydroponic greenhouse, smart greenhouse, with this computer system by the help of students. So this is your homework. This is your homework. Guys, can you hear me? Dear Khaled Shahid wrote some problems. Okay, so you can hear me. So your homework is to see some information, to check some information about Raspberry Pi, how it works, its applications. Let me send you a link here to make things a little easier for you. Second. You can use this link to see a book related to Raspberry Pi. I really encourage you to check this amazing small computer. Okay, let's return to our slides. Dear Yunusaya, I don't understand your question, but let me answer you in a general way. Raspberry Pi is a computer, is a full complete computer in the size of a hand palm, as you can see, as you saw on those images. It has everything you expect. Even it has some SD card port to allow you to connect your storage devices. Yes, it's same as a mini PC, but so smaller. It's so smaller and it's so cheap, and it's so capable. Okay, produced by Raspberry Foundation. There are multiple different small computers similar to Raspberry, but Raspberry Pi is the most famous one. Okay. In the last type of distributed systems, which is called distributed pervasive systems, or in other words, we use ubiquitous computing, or ambient intelligence. It basically encompasses a wide variety of different systems which we use in our daily routine. For example, these smart cell phones we use is part of these pervasive systems, or temperature sensors we use in our houses, or light sensors we use in our houses, or these smart driving alert signs are some kind of distributed pervasive systems. Smart surveillance systems, cameras, and many other forms of these smart bands we use. For example, Xiaomi band, Apple Watch, and many other options available to the consumers. All of these are categorized as distributed pervasive systems. Okay, these are distributed pervasive systems. So I will discuss more details after a break, a quick break, but try to check Raspberry Pi's awesome features. Let's have a quick break now. After that, we will continue to discuss uh, Internet of Things and pervasive systems. Okay, guys, let's continue. So let me show you another example of an IoT device. Okay. Okay, this image is good, so you can see what I mean by, for example, smart home. Okay, look at this image. In this image, you can see we have different devices. For example, we have smartphones, we have laptops, we have televisions, or display systems, or computers, these washing machine, these automobiles, uh, and generally all of these are connected together through cloud, which is maybe comprised of several hundreds of uh, IoT services. This is what we think that in few years every country in world will look like. Okay, and all these devices can be categorized as Internet of Things or pervasive computing device. So we have three requirements regarding these systems. Three requirements. First of all, contextual change. You know, as the environment in these systems are volatile and changing continuously, we live in dynamic environment. For example, currently you are in home, and in 10 minutes something happens, and you should go outside and check something. Your context will be changed. Your context is currently your house. You live in your home, and your family is around you. And then after 10 minutes, you should leave the house and, for example, go in the street, or even use a bus or a train to move from one place to another. And in these situations, your context change drastically. Because, for example, in a train, there are lots of people that has mobile phones, cell phones, and they can provide some services to you. Okay, the system is part of an environment in which change should be immediately accounted for. So your mobile phone, your smartwatch, your computer, anything you carry with yourself should react to this environment. And also, the environment should react to you. For example, in the train systems should account for your presence. Should account for your presence. For example, they should provide you with some information. They should push some message to your mobile phone, and do, I don't know, any other value-added services they may want to provide. Okay, they should understand that in a matter of seconds, number of passengers will increase from, for example, 10 to 100, and also in a matter of seconds the number of passengers may decrease from 200 to 10. That this is the nature train, and the smart systems we use in these environments should be aware of these dynamic and volatile contextual changes. Okay, this is the first item, contextual change. So we have three requirements regarding the pervasive systems. First one is the contextual change. Okay, anyone has a question? Can ask here. Anyone can ask a question. Okay, Okay. Second item is a second requirement is ad hoc composition. Ad hoc composition. It means in most cases we don't have, you know, the what is the meaning of ad hoc? Ad hoc. Ad hoc means infrastructure less system that has no a system or topology that has not an infrastructure. Okay, cellular phones such as 3G and 4G are or have infrastructure. So calling through cell phones use specific structure. But example sending files through Bluetooth is ad hoc because you don't need any infrastructure to perform this. For example, you think yourself, you are in the moon, okay? You are in the moon. You can transfer files with your Bluetooth to your friend near you, yes? But you cannot call through cellular phone in the moon because you don't have antennas and other infrastructure needed to relay your information from one point to another point. So in some systems we have infrastructure, and in some systems we don't have infrastructure. In systems in which we don't have any infrastructure, we have ad hoc model. Okay, we have ad hoc model. Yes, there's no network, for example, in the moon, but in that exact location, you can transfer files with your Bluetooth. Yes, because Bluetooth doesn't need any infrastructure. You just need to be near your friend. For example, if your friend is near to you, uh, you can send files with Bluetooth. You can use your Bluetooth headphone anywhere in the earth or anywhere in, I don't know, in any other location, because it doesn't need any infrastructure, but you need to be in the coverage of cellular antennas to connect to cellular network. Okay, this is not ad hoc. So cellular network is not ad hoc, and Bluetooth connection is ad hoc. Okay, everyone understand? Do everyone understand the concept of ad hoc? Yeah, guys. Because you know, in a matter of minutes, we have a quiz. We have a quiz. So you should know these things because I asked you several times, do you understand? Do you have any question? And you say, no, you don't have any questions. So in ad hoc composition, we say that each node may be used in a very different way. So we need to be able to configure the systems as easily as it can. The third item is sharing, and we say that sharing is the default. Because, for example, consider that example I told you before. You get up to a train, and Excuse me, guys. My daughter just stepped in the room, and I had to give her some toys. Okay, I told you that sharing is the default. Nodes come and go, providing shareable services. What it means is that, for example, when you are in a train, you can provide some services, for example, some files to other passengers. You can even use your mobile to provide a hotspot. Okay, you can create a hotspot in the train and provide the passengers with internet. But when you arrive at your destination and you want to go out of the train, then the services you've been provide the customers or passengers with will be gone with you. Okay, you are not there to provide a hotspot to the passengers. Okay, so sharing is the default, but we should pay attention that in Internet of Things environments, nodes come and go. Nodes come and go. Okay, this is the third important requirement of Internet of Things or pervasive systems. Let's go next slide. Okay, guys, can you see? Yeah, guys, can you see the slides? Dear Rasha Sarmad wrote, what is the difference between IOV? Okay, I will tell you. Guys, can't you see the slide? No slide? Let me check now. Okay. Please read the first paragraph. Read this paragraph and think about it. Read and think about it, okay? Okay. Also, you can see this paragraph, electronic health systems. Read all these items. It helps you to envision about the applications and opportunities of Internet of Things in different areas. Okay. Are there any questions? Or it's obvious? Yes, these examples are for IoT, for Internet of Things. And some concerns. Okay, dear Rasha Samad, you asked a question about IOV and VANET. You know, VANET is a classic term. It roots back to, I think, about 20 years ago. And VANET, or vehicular ad hoc networks, as you wrote, is the basic form of inter-vehicle communications. Okay, now with the growth of Internet of Things and smart cities and smart roads and other smart peripherals near us, we have the concept of Internet of Vehicles, because Internet of Vehicles is a subset of Internet of Things, and the VANET expanded, developed, and now we can say that Internet of Vehicles replaced this classic term, classic word VANET. Okay, so Internet of Vehicles, or IOV, is more advanced, has a wider spectrum of applications and considerations, comparing with the traditional VANET. So the VANET extended, evolutioned to this term that we call Internet of Vehicles. Basically, we can say that Internet of Vehicles demonstrates a more smart environment with much more complicated services that can be provided to customers, comparing with the simple communication that we use and we discuss in VANETs. Okay, in VANETs we really involved with usually we involved with basic communication and clustering and energy conservations and things like this. But with the emerge of smart vehicles and smart roads and different smart things here, and of course the emergence of machine learning, now we use Internet of Vehicles instead of VANET, because in the we have more advanced applications, we have more complicated workflows, and obviously more values in this area. And of course, the basic and primitive problems we had in VANETs are still there in the IOV, and they can be categorized as problems of Internet of Vehicles. I hope you got your answer. Okay, let's talk about a very specific before that, I should say a good thing that Dear Rasha Sarmat mentioned is VANET. We have MANET, VANET, and we can use both of them in different situations. In MANETs, we have mobile ad hoc networks, and VANET, we are vehicular ad hoc networks. These are two traditional terms used as a basis of modern Internet of Things in today's world. Another question from dear Rasha Sarma: difference between an ad hoc network and a mesh? Yes, of course. But it is really outside the domain of this course. Okay, what we really when I tell you about sensor networks, you will be more familiar with mesh networks. Okay, but discussing the details of these two kinds of networks is related to another course called Advanced Network, which you may had it, or I don't know, you might had it or not currently. This is a very important course. You should take it, and very, very fundamental. I will try to point some basic things here regarding the mesh networks, but you should take that course to learn the details of mesh networks. Okay, you're welcome. Okay, sensor networks. You know, we can use sensor networks let me show you a sensor network first. Sensor node, for example, Mika 2. Let me show you an image of it. Okay. Can you see the image? You guys, can you see? Okay. Okay. Look at this. This is a Mika 2 sensor node. For example, you may have any kind of sensor, for example, temperature, humidity, light, soil humidity, air humidity, motion sensor, or I don't know, any other type of sensor you can have. And then you can make a big network of these sensors, which is called sensor network. So we may have more than 1,000 of sensor nodes. For example, we can propagate, disperse them on a big farm, or in the boundaries of two countries, or I don't know, in maybe you may use them in factories to detect some activities. These sensor nodes can connect to each other and form a big mesh, or a big grid that can provide you with required information. Okay, so sensor nodes are very cheap. They're very cheap. They're very simple. They have a very small memory, very weak computational power, and also they have a very weak communication capacity. For example, they may use Bluetooth or a wireless to communicate. Simplest form of wireless network, of course. And of course, and often they are battery operated. They use battery. So running energy efficient algorithms on these networks is very, very important, and has been a very attractive area of research in the past decades. Okay, this is what we call sensor nodes. So let me go further. Okay, look at figure A. Look at figure A for a second, and I will explain it for you. Okay, here is our environment. For example, you can think this is a big farm. Okay, we have a big farm here, and we want to check soil humidity. Okay, you know what is it? Yes. For example, to start irrigation system at a specific parts. For example, this part needs more water, and then you should turn on the automatic irrigation system just for this part. Okay, or this part, or this part. This sensor network can continuously check the soil humidity, and then sends the information to the farmer's office. This is farmer's office. Okay, let me write it here. This is farmer's office. So the farmer can check the status of the soil in his big farm, with much ease. He should just type a command he wants, or use some clicks of mouse, and then he can see the status of soil and the status of the plants in each area of his farm. Okay, or even turn on the irrigation to water the plants and help them to grow better and produce more crops. Okay, this is a simple usage of sensor networks. This is a very simple usage of sensor networks. Also, you can say that this is not a big farm. You can consider this as a boundary between two countries. And this man here is an officer, is an police officer or a military officer that wants to check the border. If some activity happen in the border, he can check it with his computer, and he doesn't need to check with bare eyes and put himself at. Okay. So these are two simple applications of networks, which we can use in our automation and our smart cities environments to help the better production of goods. Also, there's the is there any question? Is there any question? I think Rasha Sarmad is typing. Dear Rasha Sarmad, do you have a question? Yes, it's correct. Yes, Masami, what is your question? You say you need another example for sensor networks? You need another example for sensor network? Dear Asma, you write a sentence, then I can understand you. Do you need another example about sensors, or you want me to explain this figure with more details? Okay, let me show you something. Let me show you something. Look at this image. I know it's not. Oh, okay, I found another image that has better quality. Just a second, just a second. Okay, take a close look. You know, here is our farm, or as it has been written on the image, agricultural field. Here we have 1, 2, 3, and 4 sensors. These sensors may, I don't know, may sense, for example, soil humidity. Okay, and then they have this operator here, this remote user here. For example, he's right. He's the manager. He's on, and this farm is in Intel. For example, Shiraz, another city. And this is the farmer, and he is currently in his son. Okay. This user wants to check the status of soil. So whether it needs to perform some irrigation. You know, what is the meaning of irrigation? Irrigation. Irrigation means watering. Basically, it means watering. Pour on a plant means irrigation. Okay, so we want to know what is the status of soil. So from his on his cell phone to connect to the internet, and then you can check the database or web server here. And these sensors continuously sends the information about the humidity of the soil to this gateway node. This is a wireless node, a cellular, for example, node. This is a computer. And computer gathers information about this field and sends it back to the internet. And through the internet, it will be recorded on this database server. So anytime and from anywhere, this user can connect to internet and through the internet they connect to this server and check the status of this field. This is the application of sensor networks. Okay, is it better now? I hope you may better with this image. Okay. So I will try to discuss more information, more details about sensor networks in the next week, inshallah. And until then, please pay attention to your homeworks. It's so important to learn in a fixed pace, okay? Learn as much as you can and use internet, other device, other their sources, for example, books, to learn about the things I told you about and get ready for the next session. I wanted to have a quiz today. I think it's late now, and should pass it. Okay. So I hope you stay well and healthy in the upcoming weeks, months, years. Yes, I know, dear Marva, because we need to have time for the course. And so we may have this presentation in the next week. Thank you for your help. Are there any questions? Are there any concerns? Thank you, Salim. You too. Okay. في أمان الله. خدا حافظ and goodbye.